Okay, hello. My name is Andrew Dunn and welcome to the Wood Solutions webinar for today entitled Understanding Fire Performance of Timber Structures under Parametric and Standard Fire Curve. What we will cover is a learning outcomes as well as a table of contents, and we'll understand how fire resistance levels are determined in the BCA, understand which methods of determining fire resistance levels are applicable to timber, and understand what is the difference between a standard fire and a parametric fire, understand where AS 1720 Part 4 can be used and what timber products are within scope, understand the changes made to the recent revision of AS 1720 Part 4. Also, we'll look at what the next research is needed in this area. So you hope to go in a very short period of time to cover all this. So we're moving fairly quickly through all of this. The CPD questions, we have three of them. Suggest you take a screenshot of this now so you remember what they are. We'll review them at the end of them, but basically what the questions are is Schedule 5 has a number of methods to determine fire resistance. Name two methods that are applicable to timber. The second question is describe the difference between a standard and parametric fire curve, including where they would be used. And the third, name two new additions to the 1720 Part 4 standard. All of those topics will be covered, will be covered in the talk. So I now hand over to my colleague, and he'll be talking about how do you determine an FRL for a building element. Right.
Okay, thanks, Andrew. So in Australia, I mentioned that because there's people from a lot of other countries that are tuning into this seminar. In Australia, we have a mandatory building code. It's called the National Construction Code. It has a number of volumes to it, and it sets out what you need to do in order to get approval for design and construction of a building. The difference between our National Construction Code and a lot of other construction codes is that we have a mandatory section up front of the code which is titled the Governing Requirements. And these are mandatory requirements. They tell you how the code must be interpreted and applied. They tell you how compliance with the code must be achieved. They have a series of defined terms, and there's a whole suite of other information that some of which we'll touch on later today. Section A is a must-read part of the code for all users. It's something that you must comply with, and it's an important part of knowing how to achieve compliance with the NCC. There are two critical definitions. I mentioned before, Section A talks about defined terms. Two defined terms that I want to emphasise are appropriate authority. Appropriate authority means the relevant authority with the statutory responsibility to determine the particular matter. So in essence, what happens is, what we're saying is that the appropriate authority is the person that users of the code need to convince that what you're doing complies with the NCC. They're the ones that say yes or no, not Andrew, not me. We can offer comment, we can offer an opinion. The appropriate authority is the determining authority. And appropriate authorities can rely on appropriately qualified persons, and that's a person recognised by the appropriate authority as having qualifications and or experience in the relevant discipline in question. So between those two, that's how we need to determine what complies with the NCC. So overall, you must comply with the governing requirements, and you must comply with what we call our performance requirements. Our performance requirements set the technical standards for the design and construction of buildings. So they are also mandatory. So the two compulsory parts of the NCC are the performance requirements and the governing requirements. Now, there's a series of solutions that you can use or develop in order to meet the performance requirements. One of them is a performance solution. Now, a performance solution is any solution that you put up that is different to a deemed to satisfy solution. So these are the deemed to satisfy solutions. They're an alternative to performance. They are standard recipes that are in the National Construction Code. The way we talk about the two differences is that a performance solution would probably be developed and used by the chefs of the world. The deemed to satisfy solutions are generally the cooks of the world. So the deemed to satisfy are recipes. It's like following a recipe book. Do this, and the government or the appropriate authority will give you a tick, likely to give you a tick. If you want to do something other than the deemed to satisfy solution, it's a performance solution, and that's where you need to convince the appropriate authority what you are doing meets the performance requirements. And you can use a combination of those two types of solution in a general building design. And we see a lot of that today in Australia, where people might do something that is 90% deemed to satisfy and 10% performance solution. Now, when it comes down to fire resistance of building elements, there's a clause in section A, it's A 5.4, and it says fire resistance of building elements, be determined in accordance with Schedule 5. We're going to talk about Schedule 5 now. So in essence, it's a deemed to satisfy provision. You don't have to do it if you don't want to, but it's a nice cookbook recipe for achieving compliance with the NCC. So now we go to Schedule 5, which is titled Fire Resistance of Building Elements. And the schedule sets out the procedures for determining the fire resistance level of building elements. Clause 2 of Schedule 5 says, a building element meets the requirements of this schedule if A, it's listed in and complies with Table 1 of this schedule. And Table 1 is basically a table that sets out different assemblies, different building construction assemblies, and then gives you the FRL that is deemed to be achieved by that assembly. This is the type of, this is an extract of that table. So you can see there that there's different types of masonry, and they will give you, depending on the minimum thickness of the principal material, they'll give you the fire resistance level that will be deemed to be achieved by that type of element. There are no timber solutions within Table 1. So Subclause B, a building element meets the requirements of the schedule if it's identical with a prototype that's been submitted to the standard fire test or an equivalent or more severe test, and the FRL achieved by the prototype without the assistance of an active fire suppression system is confirmed in a report from an accredited testing laboratory which describes the methods and conditions of the test and the form of construction of the tested prototype in full, and it certifies that the application of restraint to the prototype complied with the standard fire test. So B is basically relationship to standard fire test. Image of a furnace at CSIRO and the curve for time temperature from that furnace. Subclause C, so this is our third option. It differs only in a minor degree from a prototype that's been tested under Subclause B, and the FRL attributed to the building element is confirmed in a report from an accredited testing laboratory. In the NCC, anything that is written in italics is a defined term. So from that, we can see that accredited testing laboratory will be defined in the NCC. And that report from the accredited testing laboratory certifies that the building element is capable of achieving the FRL despite the minor departures from the tested prototype, and it describes the materials, constructions, and conditions of restraint which are necessary to achieve the FRL. So that's another option. Or, sorry, there's a definition of accredited testing laboratory. I won't go into that. The method described under subclause 2C requires independent assessment and certification, and there are a limited number of accredited testing authorities that can undertake this task. And then we can go to D. If the building element is designed to achieve the FRL in accordance with these different Australian standards for different construction materials, of which Roman 3, AS 1720 Part 4, if the element is a timber element other than fire-protected timber. So that term is written in italics, it is defined, and we'll talk about that in a tick. The fifth option, the FRL is determined by calculation based on the performance of a prototype in the standard fire test, confirmed in a report in accordance with clause 3 of Schedule 5. The calculation process is specified in a separate clause, as we say, clause 3. The calculation process is not restricted to accredited testing authorities. And subclause E is understood to be utilised by timber product suppliers at present. And then the last option is for fire protective timber, FRL determined for fire protective timber if it complies with specification C113 of the National Construction Code. Satisfy provision requires a building element to have an FRL must be determined in accordance with 5. Therefore, if compliance with Schedule 5 is not proposed, the proposal would be a performance solution. So anything other than deemed to satisfy is a performance solution. Now, there's a new clause coming into the NCC that relates to the development of performance solutions. It's expected to come in from the 1st of July 2020, and it will set aside or it will describe a process that must be used in order to develop performance solutions. This is the clause. The following steps must be undertaken when you're developing a performance solution. This process that's described in subclause 4 is similar to a process that was introduced in 1996 in Australia for the development of fire engineered solutions. And that process has been generalized to make it relevant to any performance solution, whether it's fire resistant or whether it's be stair geometry or whatever, ceiling heights, the whole lot. Anything can be determined as being a performance solution if it's not deemed to satisfy, and this is the process that you must use. So basically it's preparation of a brief in consultation with relevant stakeholders. At this stage, for the purposes of subclause A, the development of a performance-based brief, it is accepted, my understanding is it's accepted that the relevant building certifier, the person who is likely to be asked to be the appropriate authority for this project, they can be involved in the development of the brief. But once the brief has been developed and all the stakeholders agree this is the path we're going to take to develop our performance solution, my understanding is that the accredited certifier or the appropriate authority would step aside from the process, and then steps B, C, and D would be undertaken. And following the completion of D, following the completion of a report on the process, that report would then be given to the accredited certifier as documentation in support of the performance solution. One of the other things that's important in the NCC is that if you develop a performance solution, up in the governing requirements in clause A 2.2, subclause 2, it says a performance solution must be shown to comply with the relevant performance requirements through one or a combination of the following assessment methods. So the NCC is saying, once you've decided to undertake a performance solution, you offer the appropriate documentation to the approval authority, and that documentation must demonstrate compliance with performance requirements via one of the, that's in written in italics, so it's a defined term. A third one is the use of expert judgment, and that's written in italics. And then the fourth one is a comparison with the deemed to satisfy. So the deemed to satisfy have been accepted as acceptable recipes for many, many years. And in some instances, a performance solution, the proposer may prefer to demonstrate compliance directly with the performance requirement. Under subclause D, if they can demonstrate that the outcome of the performance requirement equates to the deemed to satisfy provisions, then that's an acceptable means of assessing compliance with the NCC as well. So if you're thinking of doing something different to the deemed to satisfy, you'll need to demonstrate that through supporting documentation that is consistent with A2.2. Necessarily, approval authorities are cautious. Something new is something that they are going to look at. There's something that they're going to require significant documentation for some issues, depending on the complexity of the performance requirement. And from my experience, early consultation with key stakeholders is essential. So if you're thinking of doing a performance solution, start talking to your key stakeholders, feel the water, get some indication of whether or not what you're proposing is potentially going to be accepted, and what documentation or what means of support you're going to have to offer the approval authority to demonstrate compliance. In some instances, it may be more expensive to produce supporting documentation than the potential cost savings of developing a performance solution, and that's something that you need to determine. So that's part of a strategy that you will need to develop.
Okay, right, thanks. All right, all's good out there. Changing direction slightly. What I'm going to do now is talk about AS 1720 Part 4, Fire Resistance of Timber Elements. So this is our reference standard, Australian standard within the BCA as an alternative method to determine fire resistance level. So we saw how it is caught up in regulations. And we have two versions out there at the moment, the 2006 and the 2019 version. The 2006 version is technically the version of the standard within the building regulations, and there is due tomorrow a new version of the amendment to the BCA, but the amended version of the BCA still calls up the 2006 version of the standard. So we've got a usual situation where we have a more recent version of a standard which has some more information there, but the regulatory accepted one is the older version. This talk will be on the newer version of the standard. So the first thing to note is what the scope of this document is, and this is probably the take-home point for you, is it's for the, and this is related to the 2019 version, it's fire resistance for structural adequacy, and the new new addition is installation of solid sawn timber, pole form, plywood, laminated veneer lumber, and glue laminated timber structures. And it's an alternative to the standard fire test, which is your usual picture of a CSIRO furnace. And whenever you see that, and you'll see this coming up many times now, that's an indication of your standard fire testing methodology. So, and it's interesting, it uses a term called notional charring rate. So why would a committee determine something to be notional? And what does it say? It assumes to be converting the char when exposed to fire. But notional means, based on Google, something, an estimate or theory or non-existing in reality. And that's something to remind it. It's not meant to represent the real world. It's just something which is used for calculation as an alternative method for fire resistance determination. So be wary that you start using char rates out of 720 part 4 to represent the real world. But as you can see from the time temperature curve displayed below, it's for infinity fire. So doesn't necessarily, and we'll see shortly why that's the case. So how does the notional char rate compare to the real world? Well, work was done on this about 40 years ago, and looked at a number of Australian commonly used timbers, radiata pine through to common hardwoods. And interestingly, this work looked at measured the density of the laminates that made up the element, in this case a glulam beam, and published the mean density for that specimen against the published density. And you can see there's quite a large variation. So in some of the high density materials, there's something like 200 kilograms per meter cube density difference between of the makeup of the elements. And this explains why we get variation in char when we actually do fire tests in char. So that can explain things. And this is comparison, the additional bit of the notional char rate from the standard versus experimental. Experimental data is only to 1 decimal point, and you kind of like, and we graph this, you find that it pretty much just lines up with the equation within 720 part 4. So the blue line representing 720 part 4, and the orange dots being the test data dot. The dots, and remembering they're only 1 decimal point, so there is a degree of accuracy there. And we look at others who've been doing this work. It's quite interesting. A number of researchers around the world have been comparing Australian standard versus their material. And this one is from Leeds University in Europe. And they compared a whole bunch of different density timbers, density along the bottom, and char rates per millimeters per minute, and against the Australian 720 part 4. And it's good to see that most of the timbers tested fell into the safe side of the curve, and pretty much worked well. Interestingly, when you compare this with the Eurocode, and in this case we're using a hardwood definition Eurocode, it works well. There's a couple of them above that, and we compare the graphs side by side, Eurocode versus Australian. You find that the not too bad. But there is a couple of outliers there, particularly in the Eurocode one at low density. Also, National Taiwan University has done a similar piece of work, and in this case this is 720, as the graph here, against density along the lower graph against millimetre per minute char rate in the vertical axis. And you can see from this summary that most of them appear in the line. Again, they did some research work and compared against the Eurocode. In this case, they found more of the timber was above the line in the unsafe thing than below. So when we put them side by side. To be quite honest, you'll find that the Australian curve probably matches the data better than the Eurocode. And so we go one step further, and this is another graph by Bartlett, who put together a whole bunch of researches on char rates and just put them in a big dots onto a page. Again, it's density of timbers along the bottom versus the char rate per millimetre per minute. And I've, in this case, put the Australian equation method, which is the blue line, against the European, which is the orange line, brown line, and North American, which is the grey line. You can find that the very linear, one-dimensional of the North American Europe is fine for a certain range of densities, but for high densities it's super conservative, and for low densities it's not. The Australian tends to follow the data the best. So then, really, in that conclusion was that be wary of calculation methods, and particularly for density, where they don't take account of densities. So the revision of 1720 Part 4 was published late last year, and the reason for the revision was it's well and truly beyond its normal cycle of BCA reference standards, so it was well overdue for revision. In increasing use of timber systems for whole building elements such as walls, floors, and roofs. The previous version, 2006 version, only allowed for structural numbers determination, and for barrier systems, there wasn't the insulation or integrity. The calculation method is only applicable to structural adequacy, just said that. Standard was not clear on inclusion of CLT, modern adhesives such as polyurethane, or fabricated element systems made up from smaller components. And our brothers across the ditch, New Zealand, also wanted to be able to use this standard, so they joined into it, so it's become a joint publication. So very importantly, we need to understand what products make the scope of the standard. Doesn't cover every type of timber product available. So what we need to do is to see what meets this way, and also there's a limitation on the bonds or the adhesives that are used within the standard, and I'll explain this in a bit more detail. So the acceptable timbers to meet the standard are listed in A-H, and effectively they're sawn timbers which have been graded, plywood, laminated veneer lumber, glulam, and round timbers. So they cover for most products that are available in the marketplace. And there is another one called other timber products or grades, which is section H. And the important thing here, you can use other products and grades, but they need to be their properties determined to the ASNZ S4063 series of characteristic values determinations, and the low duration factors for strength and stiffness are determined on tests. So that can be used. And what this basically does is mirror the acceptable timbers that are allowed in 1720 Part 1, which is a timber engineering standard, which kind of like makes sense. So you want to have the Part 4 of the standard series equals the Part 1. So structural adhesive is the main area where you got to be wary of, and in this case, it's only really allowing the phenolic family of structural adhesive, which we commonly see as a dark line adhesives. So the other adhesives, EPI, polyurethanes, and melamine type adhesives don't meet this. It also has a product manufacturing requirements of those for the various products. So the method of determining char, there is a number of methods, and in this case we can use the standard fire curve, which makes sense. And there's now a test procedure in A, which I'll talk more about. So firstly, it's a clarification that it needs to meet the standard fire curve. Not a cone calorimeter or a home barbecue or anything like that. It's not an acceptable way of determining char, so it needs to follow the standard fire curve. Integrity is included, but in the integrity section, it only talks about that it can be determined by a standard fire test. In this case, is a picture of an integrity an LVL floor system, which have joints in it, and this is in the 2 hours, and it's available. The assessment for this is available from Wood Solutions' website, and it includes a number of methods of joining elements together, which I'll flick through available from the assessment, which will give you 90 minutes and 60 minutes for both walls and floors, and you'll find that in barrier systems, it's the integrity which is important. The failure normally occurs in integrity than earlier than any other system. So the insulation has now been included. So insulation is a number which wasn't previously, and it has two methods how to determine. Again, the standard fire test. You just keep seeing this always appear. So if you have data from a standard fire test, you can use that. Or there's now a methodology which is required, and just reading it, it says after the nominal fire resistance period, the minimum residual width or thickness of the element provided structural separation shall be 30 millimetres. What that's trying to say is that if you want to determine your depth of char, then you need 30 millimetres of additional timber there, and you obtain insulation number. And what does that mean? Well, this is a real fire test, and you look at a point at 10 millimetres depth within an LVL element at 300 degrees Celsius. And if we move 30 millimetres further into the timber, we found that temperature was 45 degrees centigrade. So well and truly meets the insulation requirements you expect. So quite conservative method. So in determining the notional char rate, the standard now gives you three methods. And the first one is the very familiar equation of the density relationship. So this is the notional char rate, and it's at 12%, the density of timber at 12% moisture content. But importantly is a clarification that for engineered wood products, the assessment is based on our primary timber species, not including any adhesives. So you don't measure the density of the engineered wood. You measure it's the published density of the species that make up the timber. One for us lazy people is that there's now publishing a table of notional char rates instead of using a calculation method. It's based on the calculation method, but it's just published there, so it's easily read off for commonly used timbers. The exception is a European spruce. European spruce, if you use a calculation method, is not 0.65. We know from a number of testing that European spruce performs better than the calculation method, so it's been deemed to be acceptable. And we can see that is in this case here as an example in the testing we looked at earlier. Obviously, we have a test method which I'll talk about shortly, and this gives an equation which is our effective depth of char, which is again this normal procedure, which is our notional char rate, which is just determined by the time period. But the change is occurring is it's no longer 7.5 millimetres. We're now using a zero strength layer of 0.7. 0.5 millimetres was a bit of an overkill and inaccuracy for a very inaccurate methodology, and also aligns up with the Euro code. So that was seen as in a reasonable way. And it takes account of the rounding effects and temperature effects from the char to the unaffected temperature. And what does that mean in reality? If we look at that same process we looked before at the depth of change of temperature at depth, 7 millimetres will go from 300 degrees Celsius to 165 degrees Celsius within that 7 millimetres. So it kind of makes sense. So the notional char rate can be determined by tests, and it's a test procedure. I'm reminding you it can't be done by other types of systems such as coating calorimeter. They have different oxygen levels and variations, so we need to be consistent. It can be done on a small scale test furnace, so it's a minimum size or 1,000 by 1,000. It needs to be at least 75 millimetres thick, because that's the minimum requirement in the standard as well. Is that the appropriate char rate for a determined FRL is 75 millimetres, and it requires thermocouples, which are measuring your temperature through the timber at 10 to 12 millimetres apart, and from that you can calculate the char depth by using the 300 degrees isotherm. And how you can determine the overall char rate for that test is measure the overall depth of char at the end of the fire and divide by the exposure time. There's no rocket science in that one. Or using the interpolation between the depth by using isotherm of 300 degrees Celsius and just measuring the time between different isotherm thermocouple locations. And that can give you effective depth of char. Char behind fire rate plasterboard is included. It has an equation in this case which accounts for the effect of the lining. So T300 is the time it takes for the insulation to get to 300 degrees, and that's taken off the time required for the fire resistance level, and uses the same equation that we used before. The effective char but there's an addition to it. The effective char shall be calculated using a notional char rate of 2 times the effective rate for a period of the time between the insulation fell off and the effective depth of char reaches 25 millimetres. And that's a mouthful to explain, and took me about 4 or 5 times by reading this again to understand what it means. So I'll flick through this with some illustrations. So we have here is a 0 test where we have a plasterboard protected element. So we put a fire, and for a period of time, say 30 minutes, nothing happens, and then at 40 minutes, the plasterboard fell off. So at that time period, we then assume that the char rate is twice that of the standard char rate, and that accounts for the super dried timber that will occur because of the time it's been exposed to the fire below the plasterboard. But eventually, as a char layer forms on top of the forms, we end up with a more traditional charring occurring, and we can get back to calculating as we normally would. So the method is considering the effect of this. And this follows pretty much what happens with Eurocode. Code has a step approach, particularly for CLT char rates. Connectors are also included, and unprotected connectors. There is no solution there. It's regarded as negligible, so there is no solution there for unprotected connectors. There is 3 methods for protected connectors. Obviously, embed the connectors below the effective depth of char is the main one, and plug them with, place a timber plug over any dowel bolts and screws. Another method is to use fire protected insulation, which is pretty much no rocket science there again, and you can calculate that. Has a criteria which is useful for testing. Connector temperature is not to rise more than 220 degrees Celsius, or for dowels 300 degrees. Reason why dowels higher, the dowels are through the timber element. It's just and it's likely to be closer to the surface of the exposed element than equivalent to a connector. And the third method is standard fire test, which just keeps reappearing. So note that for all 3 methods, the assumption is a complete cover of the connector. Where construction gaps or tolerances are present, they need to be sealed with a fire resistance or equivalent FRL. Makes sense. And what are they? Well, I'm about to go and test those. So I've got a test schedule the next couple of weeks. And this is a picture of the specimen ready to go, waiting for a match at CSIRO's laboratory. We attended this load bearing test for 120 minutes in the next couple of weeks. So why wasn't CLT included in the standard? Well, there's no Australian manufacturing standard to ensure consistent product. So it's very difficult to put something into it. We don't know what it's going to be. And the most obvious one, that the adhesives didn't meet the requirements. So the most adhesives are not within the scope of the standard. So what about polyurethane bonded glulam? It doesn't meet the requirement, therefore it can't meet. It's outside the scope of the standard. But it does meet the manufacturing standards. So the polyurethane does meet the standard. But in this case, they're required to be an AS 1530-part test, a standard fire test again. And it's good to see that one of our suppliers and manufacturers in Australia, Australian Sustainable Timber, has conducted some testing, and they've found from a comparison between the real testing against the standard, is that they're 30% better off than the standard. So congratulations, good to see there's some value in doing some testing. And they've also done it for a high density timber in mountain gum, grey mountain gum, and in this case it's shown a 10% difference. So there is some manufacturers out there that have doing testing to the standard fire kits. So I now hand it back over to Ray.
Okay, thanks, Andrew.
Very quick, beyond time.
Okay. We're going to talk about some fire curves, a standard fire curve. AS 1530 Part 4 Australian Standard sets out procedures for and criteria for determining the fire resistance of building elements when exposed to standard fire conditions. What they are is what they are, or what they're deemed to be. Standard fire curve represents the relationship of time and temperature during a test, and test results enable the performance of building elements exposed to standard conditions to be compared. So that's basically the purpose of the standard fire curve, is a comparison of the performance of different assemblies. Other curves, parametric fire curve, they provide a method to approximate post-flashover compartment fires. They provide more realistic estimates of fire severity for a given compartment compared to standard fires, and they're dependent on ventilation and fuel load available. Parametric fire curves are simplified real fire, but they do not represent what happens in an exposed timber building. So here's an example of real fire behaviour. We're looking at something where we start with a build-up, growth in fire to a point of flashover. You end up with a fully developed fire for a period of time, and then the fire goes into a period of decay and hopefully extinguishment. Different types of curves, once again, just to sort of show rapid fire growth up front and then slower fire growth. And once again, it's the decay going down to a extinguishment. Ventilation effect on curve. Here's some different curves. The black curve is the standard fire curve. We have fuel controlled closer to the gas temperature, the lower time. And as we go out in time, we move into curves that are representative of a ventilation controlled fires. So you've got a controlled fuel load. There's the ISO 834. You've got a controlled fuel load for a different curve, and then a ventilation factor or opening factor. Another example, just to show the difference in curves, you've got 7 different curves here, one of which is the standard fire curve, which is finishing up around the 1200 degree mark, and different curves where you're having intense fire to start off with. The 7 different curves are listed down the bottom. The standard fire curve, as I say, the ISO curve is the common black line, goes all the way through, and you can see the effect of the application of different types of curves. So these curves tend to have higher temperatures during early stages, and therefore higher char rates for your timber. And down here we have less intensity over time and less char. And the thing that we've mentioned constantly through the presentation is that the standard fire curve just continues on. So what does a real fire look like? This is a fire test that was undertaken through Wood Solutions some time ago. What we're looking at is a compartment where if you look at the left-hand side of the diagram, it represents a corridor. In that corridor, there was a door into a room, and then in that room at the right-hand side of the diagram, there was an opening with a perpendicular wall system at right angles leading up against the edge of the opening. So we had a fuel load, timber cribs to represent the fuel. They were placed inside the room. That's the opening that you can see. To the right of the assembly, you can see the return wall, the external wall. The inside and outside of this assembly was lined with 2 layers of 13mm plasterboard. The cribs were lit, and you ended up with fire developing within the room, coming out through the window, and then running up the facade. This was the curve that resulted as a result from those tests. It was a comparison of timber stud versus steel stud, and you can see the parametric curve that resulted. So we have different stages of fire growth and then decay as compared to standard fire test, the green line. And at the end of the fire test, that's some of your residual timber framing after 20 minutes, or in excess of 120 minutes, was closer to 2.5 hours of exposure. So the fundamental assumption behind fully protected timber in deemed to satisfy was achieved.
Thank you, Ray. So moving on, what's the effect of fire with timber being exposed in mass timber buildings? So we looked at what timber frame is now. And the piece of work which the NRC from Canada, the National Research Centre in Canada, has publicly available information is a good example. And there's many other places around the world that have also done very similar testing, but this one is quite clear. So this case is looking at a compartment in the size of 9 by 4.5 by 2.7 metres high, CLT in this one, and fully with furniture as a fuel load at 550 megajoules per metre squared, and with an opening of the in this case, two openings they looked at, and a series of tests were done looking exposing the levels of CLT to the compartment. So this first test was nothing more than first test was conducted, which encapsulated the CLT with 3 layers of plasterboard, and you can see a curve being produced from that, and heat release rate occur and a decay as we expect, and as Ray already explained. Now, as we change the ventilation, we can see that in this case is the same setup before, but we had a different size opening. So the opening size is twice the size, and we end up with a slightly different curve. So if we overlay those two curves, we can demonstrate and see the effect of ventilation has on the heat release rate. So we've ticked the box off, and now actually know that the parametric curves, which are ventilation controlled. If we continue on, in this case we're exposing one wall. And we find that the curves are a little bit different to the baseline tests, which is the green line. There's the walls contributing to the fire. The exposed element of the elements are contributing to it, and that's best encapsulated with the pink line at the bottom. So it's the difference between the blue and green line equals the pink line, and that contribution is that contribution is coming from the timber. So as we go one step further and we expose just the ceiling, we find we get a different performance. So in this case, the baseline test, which is all encapsulated system, is the red line, and the blue as being the exposed ceiling, and the pink again is being the difference between the two. So we can see from that testing that the timber does contribute to the fuel load, and it's a different fire performance than we would expect from a completely encapsulated system. So it's something that fire engineers need to account for in their fire engineering design of mass timber buildings. So from the test program, we can kind of like see that the amount of timber being exposed, it changes the fire curve. The location of the exposed timber changes the fire curve, so wall versus ceiling, and the size of the opening. So these things are criteria which need to be included in considering a fire design. So when we look at the char rates, and I'm being mindful of the time we have left, I'll just quickly go through this. Some Norwegian university has done some comparisons of a standard fire versus and for CLT elements, and just flick through that very quickly. And they found that the char rate for this varied from 0.5 to 0.7 millimeters per minute. And they also did it on the parametric, and got a completely different char rate. So for the same exposure period, 120 minutes, the char rate was 2.6 times less than the standard fire curve char rates. So the reason being, if we look at both curves that were used, and we can lay them over each other, we'll find there's additional energy from the standard fire curve, which is equating for giving for the different char amounts or char depth. So we kind of like expect it. So we can't really use standard fire curve to as char depth as representing the char rates of parametric fires. It's a totally different beast. But we initially have a higher char rate, and then with time we'll drop down. And some work done by Lang, it's kind of like showed this. This is unfortunately rushing through this a little bit. Char rates, millimeters per minute on the vertical axis, and this is depth of into the sample from the fire exposed side. We find that the red and blue line are the standard fire test curve again, and we have a rapid heated fire, which is the green line, which is much higher rates of char rate compared to the slow heating of test 4, which is the purple line. Remembering those curves that Ray talked about earlier on. So depending on what the heat release rates are, or the exposure, then we get different char rates of timber. So it's not an easy. There is no one easy char rate for timber. It depends on the ventilation, on the heat of exposure, and time period. So in closing, the recent trend in post and beam structures that have exposed underside of floors and beams, they do not meet deemed satisfied, so they will need fire engineering. We've all seen last week the announcement of the 40-storey timber building in Sydney, the hybrid, and quite exciting times for us here in Sydney. So in summary, we are asked to provide an understanding the performance of timber structures under parametric and standard fire curve. Limited time available. We obtain compliance, how to obtain compliance in NCC, how to determine the fire resistance levels, and the relevance and revision of 1720 Part 4, and the difference between standard and parametric fire curves, and the difference between parametric and standard char rates. We found the standard fire curve is for the assessment of deemed satisfied fire rated building elements, term fire resistance level. And Schedule 5 of the NCC gives you 6 methods, not all are relevant to timber. Parametric fires are simplified real fire curves published in the Eurocode. May not represent the fire dynamics in exposed mass timber building. Fire engineers to account for the contribution of the timber to the fire load. What was missing is the fire dynamics of exposed mass timber buildings. But research is currently being conducted on this subject, and to date there's been focus on small room size for residential buildings. But what is missing is for the open plan building that we seem to be using this exposed timber in. So some good news there is that we're currently planning to do a full-scale test of an open plan building to provide this missing data. It has a tongue-in-cheek name called Project Inferno, and it's just on these early days of starting. Proposed to occur later this year or early next year, and we're currently seeking funding partners. So send checks to us here at Wood Solutions, and at that point we complete. So we are now open for questions. It's now 12 o'clock. I am going to we're going to stay around and carry out some questions for people who wish. People who do not want to hang around, please feel free to go, and we'll sort of try to answer some of the questions. But before you go, we just want to make. So what we'll do now is just finish up the presentation and thank the relevant people, but also we'll come back. I want to note that the next Wood Solutions webinar next week, same time, is on the Monterey Kangaroo Point CLT apartment building in Brisbane, which is quite an interesting one. It's currently under construction, so a very interesting presentation to hear from them. The site is a very difficult site because it's near or on top of a road tunnel, so it'd be interesting to see how they got around that. Just a reminder about the CPD questions. Take a screenshot of that. So at this point in time, I'd like to thank Ray for his talk and the time. and anybody who wants to hang around will be here for another 5 minutes and happy to answer questions. But anybody needs to go off and do something else, please feel free. So thank you for your time. Okay, I assume that anybody's wanting to is gone. So we'll just now flick through some questions. Okay, we've got a couple here from Nick Houston, which thanks Nick from XLAM. They're quite good questions. His first question is, for protected timber, where would you find the T300 for plasterboard? Our experience in fire testing with plasterboard also highlights the impact of fixing specification layouts and having an impact on the performance. Yes, Nick, I can answer that question for you. You need to do a standard fire test to get that data. And our favourite standard fire tests, I like to get $1 every time that was mentioned today. So unfortunately, you need to use real data for that. And remembering that plasterboard is not the only system you can use. You could be using a fabric such as a TBA 5 flies fabric, or it could be an intromescent coating or something like that. So there are different ways of achieving that. So that would have to be based on the standard fire curve again. So another question from Nick, and I shall read it out again. What tip do you have for specifiers looking to understand the difference between suppliers of mass timber elements and reconcile differences between testing done locally and overseas? I see a lot of difference between tests normally conducted to 1530 Part 4 and some not being loaded, including joints, etc. So I'm going to hand that one over to Ray and ambush him on that. So he's saying overseas test data versus compliance with Australia.
If you were to use overseas test data, then that would be, well, assuming that it's not standard fire test, that would be a performance solution, and you would need to develop a performance solution from the 1st of July. You'd need to develop it in accordance with A2.2 subclause 4, which is requiring you to sit down with your stakeholders, including your appropriate authority, and agree on a means of demonstrating compliance. The acceptance of overseas data is purely up to in my view, it's purely up to the appropriate authority. They're the ones that are going to have to say yes or no to your proposal. So you really need to sit down and convince the appropriate authority, or try to convince the appropriate authority that what you're doing meets the performance requirements of the NCC.
Okay, and also I'd add Ray went to great length to explain that the BCA has Schedule 5 is the only way to meet the deemed satisfied. So the Schedule 5 for timber only has two methods, 1720 Part 4 or AS 1530 Part 4. So you only got, if you don't meet any of those, then you're in performance solution. So it's quite easy. It's easier to do a test, is what it will end up being. So just scrolling down with some more questions, another one for you. This is one from Anthony. Can you please elaborate more on what assessment means in addition to the accredited standard fire tests?
If under the NCC, if you were to develop a performance solution, then the NCC requires you to demonstrate that the performance solution it has been assessed in accordance with one of the assessment methods listed in the NCC. And those assessment methods are, by definition, evidence of suitability, and there's a whole section on evidence of suitability, what should or can or be considered as evidence of suitability. The other one is another assessment method is to use a verification method. That might be a verification method in the NCC, or it might be some other verification method such as software modeling, etc. You can also, another assessment method is expert judgment, which is the judgment of a person that has the qualifications, experience, expertise to be able to determine whether a proposal satisfies performance requirements. And then the fourth assessment method is a comparison of your result, your proposal, and the result of that proposal compared to the result of the application of a deemed to satisfy provision. So if you're deemed to satisfy, if the deemed to satisfy provision was to produce a result that equated to the number 10, then the NCC says, well, if you can demonstrate that your performance solution will also achieve the number 10, that's a means of determining compliance with the performance requirements.
Another one for Ray. Andrew wants to know, 1720 Part 4 2019 version, it's a better standard. How can it be used if it's not referenced in the BCA?
Yeah, the good question. The reference documents in the NCC are referenced in a schedule at the back of the NCC, and it's the addition of the Australian standard listed in that schedule that is the one that is deemed to satisfy. If you want to use an Australian standard that is a different addition to the one listed in the schedule, you would have to do it as a performance solution. Okay. This has happened in the past. There's been several occasions where, for different reasons, the Australian Building Codes Board hasn't accepted or hasn't been able to include a new Australian standard. It might be a scheduling matter where the standard had to be produced by a particular date in order to be adopted by the next edition of the NCC, or it could be something that there was an inconsistency in the content of a new Australian standard with something that's in the NCC. But the important thing is you can still use the new standard, but you would have to use it as a performance solution.
A question from David. Can you comment further on CLT not having an established standard and testing by AU manufacturers? Well, it's a very new product, and there's only one manufacturer, two manufacturers in Australia at the moment using different timber species. So there's not enough mass at the moment for it to create standards. Standards are about when there is a number of providers looking for a consistent way of doing things, and you only have two of them. There's not enough of them. So with time, if there was enough manufacturers of this product in Australia, then you may look at developing a standard to comply with. But it's still very early days for the product before we can start thinking about putting it into a standard. So I just had a question there. Unfortunately, I just flipped past it. One from Andy from Buchanan. Are there any requirements to use parametric fire curves, or is the choice of fire exposure up to the fire engineer or the local authority for each building? Ray.
Fire resistance levels, Andy, are required to be determined in accordance with the methods available in Schedule 5, and they predominantly relate to results based on standard fire tests. So if you wanted to use a parametric curve or another predictive model of performance, then that would have to be used or offered to be applied to the design of the building as a performance solution. And once you get into performance solution territory, you're then required to prepare a submission in accordance with the new provision that was scheduled to come into effect tomorrow. That was the new provision relating to the development of performance solutions was subject to cost-benefit analysis, and as at yesterday, I think it was still on track to be introduced as from tomorrow.
Okay. All right. We'll have a couple more questions and we'll wrap it up. There's just a question that I'll answer from Andrew again. Just to confirm, CLT is not able to be used in fire-rated situations without protection. That's not correct. There's a number of deemed to satisfy, and I'm assuming you mean deemed to satisfy is the first thing. You've got to also remember straight away that you can that the NCC allows you to do a performance solution, which allows you to do anything. So it doesn't necessarily need to be encapsulated for that situation. So that's number one. Number two, if you meant for a deemed to satisfy, then there are systems which don't need, which there's more than, it's related to, your questions are really about fire protected timber. Fire protected timber has a certain applications of buildings that it can be used in the low to level building range. And I always give an example for a class 2 type building, 2 stories. I've given up counting. Last time I found 6 or 7 different ways of meeting the fire resistance in the BCA for a 2-story apartment building, and half of them are methods which don't require a fire protected timber. They just require a fire resistance level being determined, which means it could be exposed timber. So the answer is that there is lots of solutions, more in the low level buildings. The deemed satisfied, and when you get above 4-story, tends to require the use of fire protected timber, and that's what the deemed satisfied. You can build to whatever height you like using a performance solution. And I think on that point, we can probably sing one more, Ray. Okay, one more from a Travis. Some of the clear industry issues appear to be in the assessments used for justification of exposed mass timber buildings and not appearing to correctly review the impact of the FRL. I try to use FRLs with exposed timber. Not quite sure there's a question there, right?
Yeah, I'm just wondering, it's looking at some of the clear industry issues. I think the thrust of the question was that there is if people are proposing to take up contemporary means of design and construction that are beyond deemed to satisfy provisions, and you're moving into performance territory, then it might be up to industry association, it might be up to certification industry to try and sit down and work out a consistent approach from in support of the approval authorities. If they're getting different levels of information and contradictory information or inconsistent information from proposers of contemporary methods of design and construction as performance solutions, there really needs to be an effort made to get consistency amongst them. And once you get consistency and you get approvals being granted for contemporary methods, it's more likely that the next proposal would be accepted as well. So it's probably an industry thing that to get to join together and come up with a consistent approach to achieving outcomes.
Okay, thank you, Ray. At this point in time, I'd like to wrap it up, and thank you for all attending. We had 650 registered, 500 I think were attended. I can see there's still 220 still there. We had 20 countries who registered, 5 continents, so we're doing really well. I hope you enjoyed this. This presentation will be available as usual from the Wood Solutions collection of webinars, and we look forward to seeing you next week. Thank you very much and enjoy the rest of the day.